Okay, let's take a look at example 2 from our sheet from class the last day I saw you. It says a plane increases its speed uniformly from rest. So that means VI is 0. Uniformly from rest and reaches a speed of 50 meters per second. So VF is 50 meters per second in 10 seconds. So delta T is 10 seconds. What is the object's acceleration? You're looking for A. And what distance did it travel in this time? You're looking for delta D. So first you're looking for A, and you have VF, VI, and delta T. So you don't need to use one of the brand new guys. You can actually use A equals VF minus VI over delta T. Okay, so A equals VF minus VI over delta T. And again, don't have to rearrange. VF is 50 meters per second minus 0 meters per second divided by 10 seconds. So 50 over 10 is like 5 over 1. So 5 meters per second squared is the first part of the question. The second part of the question says, what is the distance the object traveled in this time? Delta D. So if I look up here, I have two equations that have delta D in them that have an A and a VF and a VI. I'd probably go with this one because then I wouldn't have to rearrange it. So I'd probably use, whoops, drop the pen, delta D is equal to VI delta T plus 1/2 A delta T squared. Okay, VI is 0, so if VI is 0, this VI delta T term is all going to be 0, right? So even though time is 10 seconds, when you multiply 10 seconds by 0, it'll be 0. So lots of times I will just do this and indicate that it goes to 0. So then delta D is equal to 1/2. A we just found, 5 meters per second squared, and the time we were given was 10 seconds squared. So square the 10, it's 100. 100 times 5 is 500. Take half, 250 meters. Part B is done. Okay, example number 3. Calculate the stopping distance. So you're looking for a delta D, how far a car is traveling. Calculate a stopping distance of a car when going 4 meters. Sorry, I just have books in the way and I can't get it. There we go. When going 4 meters per second when the driver applies the brakes. Okay, so we're looking for stopping distance. We have the VI, it's 4 meters per second. When the driver applies the brakes to slow down to a stop, VF is 0, at a rate of negative 10 meters per second squared. So A is negative 10 meters per second squared. And that's supposed to be a slash there. There's a misprint on the question. Right there. Okay, so what equation do I know that has a delta D, a VF, a VI, and an A? When I go up here, can't use this one because I don't have time, but I can use this one, right? So the VF squared equation does not have time in it, so we use it often when we aren't given a time and don't need to find it. Okay, so VF squared equals VI squared plus 2A delta D. And I'm looking for delta D. So I need to get the term with delta D in it alone, which means I need to subtract the VI squared. And now to get the delta D alone, divide both sides by 2A. So delta D is equal to VF squared minus VI squared over 2A. So VF squared is 0, so you could either write out 0 meters per second squared, or you could have just put this line through it to say it's not there, minus brackets 4 meters per second squared over 2 times negative 10 meters per second squared. Now notice this minus is not inside the bracket. What that means is that when you square it, you will get negative 16 meters squared per second squared. The negative doesn't get squared. And on the bottom, you have negative 20 meters per second squared. Divide the 16 by the 20, and you're going to get 0.8. and then meters per second squared per second squared, divided by meters per second squared. Dividing by a fraction is the same as multiplying by the reciprocal. So second squared over meters. The second squared cancels, 1 meter cancels, and you're left with meters, which is what you want to be left with because that's what delta D is measured in. Okay? So hopefully these are making sense to you, that they're all right. So if they are, and if they were, then you probably went on and started this sheet, which is your displacement, velocity, acceleration sheet. And I asked you to try the first 6. So I just need new paper. All right, so number 1 says a biker passed a lamppost at the crest of a hill traveling 4.5 meters per second. So VI is 4.5 meters per second. She accelerates down the hill at a constant rate of 4 meters per second squared. 4 meters per second squared is the acceleration for 12 seconds. Delta T, 12 seconds. How far does she move? You're looking for delta D. So again, remembering these guys, and which one would I use if I have a VI and a delta T and I want a delta D? I'd use this one. So delta D is equal to VI delta T, 1/2 A delta T squared. Again, I don't have to rearrange, but don't get used to it, it won't last. 4.5 meters per second times 12 seconds plus 1/2 4 meters per second squared times 12 seconds squared. Delta D equals 12 by 54. I think that's 54 meters. And 144, 288 meters. And so when you add them together, you should get 342. 342 meters for number 1. Number 2, an airplane accelerates from a velocity of 21 meters per second. So that's my VI. At a constant rate of 3 meters per second squared. That's my acceleration, always in meters per second squared, over 535 meters. Delta D, 535 meters. What is the final velocity? Looking for VF. So I would use, I have VI, I have A, I have delta D. I would use VF squared equals VI squared plus 2A delta D. So VF squared equals 21 meters per second squared plus 2 times 3 meters per second squared times 535 meters. VF squared equals, this is 441 meters squared per second squared, 1070, so 3210, I think. Meters squared per second squared, so when you add it together, 3651 meters squared per second squared. Take the square root, and you should get 60.42 meters per second. Number 3 says, a race car can be slowed down to the constant acceleration of negative 11 meters per second squared. If the car is initially traveling VI 55 meters per second, how many meters will it take to stop? VF is 0, and you're looking for delta D. So again, no time. You have A, VF, VI. It's going to be VF squared again. VF squared is equal to VI squared plus 2A delta D. Rearranging for delta D. So VF squared minus VI squared is equal to 2A delta D. Divide both sides by 2A. So delta D equals VF squared minus VI squared over 2A. So 0 meters per second squared minus 55 meters per second squared divided by 2 times negative 11 meters per second squared. On the top, you're going to get a negative,